Capacitance of a spherical capacitor or cell where outer surface is earth. Positive charge is given to the inner surface of the spherical shell A, and there will be induced negative charge induced on the inner surface of the outer shell B. This is induced negative charge, and the outer surface of the shell B is connected to earth, and there will be induced positive charge that will move to earth. O be the center, and we consider 2 points A and B on the surface of the two spherical shells A and B. A is the small a is the radius of the shell A, and small b is the radius of the shell B. Shell B, radius of the outer shell B. Let plus Q be the charge, plus Q be the charge given to the inner surface, of minus Q be the charge induced on the inner surface, of the spherical shell B. Inner surface of the spherical shell B. Of radius B. Plus Q be the charge which is given to the inner surface of the shell A, and minus Q be the charge induced on the inner surface of the outer shell B of radius B, and B is the radius of the outer shell. The capacitance of this spherical shell, or spherical capacitor, is C equal to Q by V. Equation 1, because capacitance is the ratio of charge given to the spherical capacitor and potential difference between the two shells. Now the potential difference between the two shells, spherical shells A and B, spherical shells capital A and capital B, is given by, that means a potential difference between these 2 points A and B is V equal integration dV A to B. Lower limit is A and upper limit is the radius of the outer shell B, is equal, since we know that field intensity is equivalent to magnitude of potential gradient, that is dV by dr. Actually E is equal to minus dV by dr, but here we have to consider E as only dV by dr. So in place of dV, what we can write? E dr. So we get integration A to B E dr. The electric field intensity at a distance r, electric field intensity at a distance r between the two shells is given by E equal 1 by 4 pi epsilon 0 q by r square. We can assume that the charge to be concentrated at the center of the spherical capacitor, so we get E as 1 by 4 pi epsilon 0 q by r square, and putting this expression we get V as integration 1 by 4 pi epsilon 0 it was V as integration a to b e dr, 1 by 4 pi epsilon 0 and q are constant, so we can bring 1 by 4 pi epsilon 0 and q outside the integration. 1 by 4 pi epsilon 0 q integration a to b r to the power minus 2 dr, 1 by 4 pi epsilon 0 q 1 by r minus 1 by r a to b. Limit is, lower limit is a and upper limit is b. 1 by q by 4 pi epsilon 0 1 by r minus 1 by r becomes 1 by r by changing the limits b to a. So 1 by r q by 4 pi epsilon 0 1 by a minus 1 by b minus 1 by b is equal q by 4 pi epsilon 0 b minus a divided by a dot b, q by 4 pi epsilon 0 b minus a divided by a dot b. We get the potential difference between the 2 points a and b of the two spherical shells, and putting this expression, this is equation 2, and we have capacitance C as q by v. Now putting the expression of v, we get what? Finally we get the expression of capacitance, which is 4 pi epsilon 0 b dot a divided by b minus a. This is what the capacitance of a spherical capacitor. Capacitance of a spherical capacitor. Capacitance of a spherical capacitor. Spherical capacitor of radii A and B. A and B. A is the inner radius and B is the outer radius. A and B, provided the outer surface of the outer shell, the outer surface of the outer shell, outer spherical shell is connected to earth, and also charge is given to the inner surface of the inner shell, inner surface of the inner shell. Inner surface of the inner shell of radius A. Now additional information. In the first diagram we have two spherical shells and the outer shell is connected to earth. If outer shell is connected to earth and charge is given to the inner surface of the inner shell is earthed, then expression of capacitance of this spherical capacitor is 4 pi epsilon 0 A dot B divided by B minus A, where B is greater than A. B is the radius of the outer shell, A is the radius of the inner shell, and here B is greater than A. Now in the second case, inner shell is connected to earth and plus Q charge is given to the inner surface of the outer shell. Positive charge plus Q is given to the inner surface of the outer shell B, and there will be induced negative charge minus Q be the induced negative charge induced on the inner surface of the inner shell, and we can denote the center O be the center of this spherical capacitor, A be the radius of the inner shell, and B is the radius of the outer shell. In this case, if the inner shell, if the outer surface of the inner shell A is earthed, outer spherical shell is earthed, then the expression of capacitance will be C equal to 4 pi epsilon 0 B square divided by B minus A. B square divided by B minus A. This is the expression of capacitance of a spherical capacitor in which outer surface of the inner shell is connected to earth and charge is given to the inner surface of the outer shell of the spherical capacitor.